Good afternoon, everybody. I'm sorry that we couldn't meet in person today, but I would like to welcome you and say thank you for viewing my presentation. This presentation is entitled Next Steps, Important Considerations for Moving Your Data and Formats into CAS. My name is Kevin Russell. I'm a consultant in SAS Tech Support. I work in the Foundation Group. My primary focus is the data step and macro, but in the last few years, I've been working quite a bit with CASUTIL. So in today's presentation, we're going to discuss three main considerations. First, I'll discuss the change in character encoding you'll likely encounter when you load your data set into CAS. Next, I'll discuss loading your data in parallel versus loading it serially. The third thing we'll consider is that the resulting CAS table will likely be larger than the source data set. And finally, we'll combine everything that we've learned and we'll go over two examples. The first summarizing how to move or load your SAS data set into CAS, and the second showing how you can load your user-defined formats into CAS. The first thing we'll consider today is encoding. We'll discuss what is encoding, the types of encoding, and then transcoding your data into the new encoding. So what is encoding? When you're storing your data, characters are mapped to numeric values, which results in a table of all code points known as a code page. This set of integers in the code page are mapped to a sequence of binary codes that get a character encoding scheme, otherwise known as an encoding. So simply put, encoding is the way characters are stored on your computer. In your SAS session, you can view your session encoding by submitting a proc options. This proc options will write your SAS session encoding to the log. I executed this proc options on Windows, and so we can see that the encoding is WLatin1. You can see the encoding of your SAS dataset or CAS table by using proc contents. This proc contents, again, was executed on Windows, and so the encoding for this data set, again, is WLatin1. So now let's discuss the different types of encoding. Most of our users in SAS 9 are going to be using a single byte Western language encoding by default. This is going to be WLatin1 if you're running on Windows and Latin1 if you're running on Unix. A single byte encoding just means that each character is stored as a single byte of memory. The other type of encoding we'll need to consider is UTF-8. UTF-8 is becoming the most used and preferred encoding. This is because it's capable of representing all the characters used in modern software. So as a result, UTF-8 is the only encoding available in CAS. This slide shows the number of bytes needed to display different characters. So for US English or ASCII, this is going to require 1 byte to be stored. In the Eastern European languages, Eastern and Western European languages, including Turkish, Hebrew, and Arabic, those require 2 bytes to be stored. With the Asian languages, Chinese, Japanese, Korean, each character requires 3 bytes to be stored, and some of the uncommon Chinese, Japanese, and Korean characters require 4 bytes. Let's take a look at an example. In this example, I'm going to show you the difference between WLatin1 and UTF-8, how it stores a value. In this example, we're going to look at the difference in how these two encodings store the registered trademark symbol. That symbol can be seen in the middle of the slide. It's just a circle with the letter R in the middle. In WLatin1, this symbol is stored as in WLatin1, this symbol is represented by an AE in hex. However, in UTF-8, it's going to be stored as 2 bytes. So it's represented by a C2 AE in hex. The registered trademark symbol is an example of a character that will cause an error if you don't take any action when you're loading the data set that contains that character into CAS. If we load a SAS data set into CAS that contains that registered trademark symbol without adjusting for that symbol, we'll get this rather lengthy error message when we load the data set. Now, as far as error messages go, I really like this error message. This error message is very specific. It tells us exactly what the problem is, and just as importantly, it tells us how to fix it. This error message lets us know that the character data was lost, or some character data was lost during transcoding, and that the data contains characters that are not representable in the new transcoding, or the new encoding rather. It also tells us that the error message can be prevented by using the char multiplier equals option, which is available within CASUTIL. The char multiplier equals option is available within the import options parameter, CASUTIL. This option specifies the number of bytes per character to use when you're storing your character data. So basically, this option gives your character variables more room to breathe. The registered trademark symbol can't be represented by a single byte in UTF-8, so we need to give the character data more space to store it. Here's an example of using the char multiplier equals option in CASUTIL. We know our data, so we know that we don't have any characters that would require more than 2 bytes to store the character. So in this example, we're setting the char multiplier equals option to 2. So now when we load that data set into CAS running this code, there's enough space for the registered trademark symbol to be stored, and the data is loaded without any error messages. Our second consideration today is going to be the transfer method we use to load the data set into CAS. In this section, we're going to compare serial loading of data versus parallel loading of data. And then once we have a better understanding of both, we're going to take a look at an example. This graphic shows you a serial load of a SAS data set. A serial data transfer involves a sequential transfer of the data through a single channel from the source of the data to the destination. This data transfer method is the most flexible and it's always available. The most common condition that will require you to use a serial data transfer is when your data source is only accessible by the CAS controller. In this example, the CAS lib that contains our data set is only accessible by the CAS controller. So when the data is transferred via a serial data transfer to the controller, it's then going to be redistributed. The data is going to be then redistributed to the CAS workers. Although a serial data transfer is always available, it's not the fastest way to load your data into CAS. If a parallel data transfer is available, then this is going to be the preferred method of loading data into CAS. A parallel data transfer allows the data to be concurrently transferred across multiple independent connections between the data source and the destination. This method greatly increases the speed in which your data sets can be loaded into CAS. Two primary requirements for a parallel data transfer into CAS. The first is that your deployment is an MPP deployment, meaning that it consists of multiple CAS workers, like we see in this slide. And the second is that each of the CAS workers, sorry about that, I got a little ahead of myself. The second is that each of the CAS workers has direct access to the CAS lib that contains the SAS data set you're loading. So in this slide, we can see that each worker has access to the CAS lib that contains the test data set. So when this data set's loaded in parallel, the data is loaded simultaneously directly into each of those CAS workers. Here's the code I used to load the test data set into CAS using a parallel data transfer. What gives me the ability to do this is that my CAS lib, my CAS lib is a shared file system that's accessible by each of the CAS workers. So that this CAS lib statement defines the my CAS lib, and which happens to be a shared file system. With my data set in this location, I can use the CASUTIL code to load my data set into CAS. If we look at the import options, we can see that I'm using the DTM equals option. This option allows me to set the data transfer method. So in this example, I'm setting the data transfer method to parallel. You also see that I'm using the debug equals option, and I'm setting this option to a value of DMS GLV-LI. And what this option does is it's going to write a note to the SAS log when we run this code that's going to let us know which mode of transfer we use. Did we transfer it in parallel or did we transfer it serially? Here's a log generated by that CASUTIL. This slide is a little busy, but I did want to point out two pieces of information. The first is the note that lets us know that the data was transferred in parallel. The second is the amount of time it took to load this data. This data set's fairly large, about 15.6 gigabytes, so it took 3 minutes and 10 seconds to load. To show you how much faster a parallel load is, I loaded the exact same table, but this time I set DTM equal to serial. We can see the note in the log that lets us know that the data was loaded in serial mode. Now if we look at the real time, we can see that it took about 8 minutes to load this data set. That's about 2.5 times slower than it was when we loaded in parallel. So if you have the ability to load your data in parallel, then as you can see, it's going to be much faster. Our last consideration is going to be the size of the CAS table versus the size of your source data set. Something that you'll notice when a SAS data set is loaded into CAS is that the size of the CAS table is going to likely be larger than your original SAS data set. Although CAS is designed to run large-scale analytics on big data, you still have a finite amount of memory available on each worker. So to maximize efficiency, you're going to want to reduce the size of your CAS table and use the least amount of memory as possible. This section discusses why your CAS table can be larger than the original data set, and also how you can reduce the size of the table using the new VARCHAR variable type. The first concept in this section that we're going to need to understand is data structure alignment. Data structure alignment is the way that data is arranged and accessed in computer memory. Aligned access is faster because the external bus to memory is not a single byte wide, but typically 4 to 8 bytes wide. So we're accessing 8 bytes at a time versus just a single byte. Well, obviously, your data isn't going to always be a multiple of 8 bytes wide, so your data is going to have to be padded with blanks to reach that 4 or 8 byte boundary. And it's this padding that takes place during data structure alignment that is the reason why your CAS table is going to be larger than your SAS data set. A way to help with this size increase is to use the VARCHAR variable type. The VARCHAR variable type is a new variable type for CAS. The VARCHAR variable type consists of two main characteristics. The first is its length is determined by the number of characters rather than the number of bytes. And secondly, the length varies from row to row depending on the characters in that variable's value. So for example, if we have a total length for the VARCHAR variable is 10, values with a length of less than 10 are not padded with blanks. An important aspect of the VARCHAR variable type is that there is a 16-byte overhead to use this variable type. Because of this, the VARCHAR variable type is only recommended for variables whose values consistently exceed 16 characters. Also, the VARCHAR variable type provides the most benefit for variables whose values vary greatly in length. So let's take a look at an example of taking advantage of the VARCHAR variable type. I have a sample data set with 5.5 million observations. It has 30 character variables, and 15 of these variables have a length of less than 14, and 15 of the variables have a length of up to 100 characters. So when we load our data, or we load our table into CAS, our data set into CAS, we want to make sure that only variables that have a length of 16 or greater are converted to VARCHAR. We can make this happen by using the VARCHAR conversion equals option within CASUTIL. So to make only variables with a length of 16 characters or greater converted to VARCHAR, we set the VARCHAR conversion equals option to 16. To show the benefits of the VARCHAR variable type, I loaded this data set twice. Once using the code we just saw to convert variables with a length of greater than 16 to VARCHAR, and once for no variables were converted to VARCHAR. And this shows the final results. Our original data set was 15.6 gigabytes. When we loaded that data set into CAS using only character variables, no VARCHAR variables, the size grew to 16.1 gigabytes. However, in this case, when we converted the variables to VARCHAR, the size of the CAS table actually was reduced to 7.2 gigabytes. So as you can see, using the VARCHAR variable type is a powerful tool that you can use to help you control the size of your CAS tables. So now let's put everything together and everything we discussed and work together through some examples using the char multiplier equals, the data transfer method or DTM equals, and the VARCHAR conversion options. This slide shows the code we can use to load a SAS data set into CAS. The first line of code is going to be our CASLib statement. This statement creates the myCAS CASLib located in the directory listed on the path equals option. The second step is going to be our CASUTIL. This step loads the test data set into CAS. This data set is located in the myCAS CASLib. We're going to write that data set out to the CAS user CASLib, and the resulting table is going to be called all together. When we're loading this data set, we want the character variables with a length of greater than 16 to be converted to VARCHAR. So we set the VARCHAR conversion equals option to 16. Also, in this data set, we know we have characters like the registered trademark symbol. So to accommodate for this in UTF, we're setting the char multiplier equals option to 2. Finally, we're going to set the DTM equals option to auto. Setting of auto will always perform parallel data transfer if possible, and if it's not, then it resorts to a serial load. So the data set that we just loaded also has a user-defined format associated with it, so we'll need to move that format into CAS too. So the easiest way to move a format into CAS is to create an output data set from the SAS format, move that data set to a location that can be accessed by CAS, then use the data set to recreate the format in CAS. So the first thing we need to do is have 2 live name statements. The first live name statement points to the location of my format catalog. And the second live name statement points to the location of where I'm going to write the output data set created by proc format to. Our next step is going to be actually to write the format out to a data set. This is done by using the control out equals option on the proc format statement. So now that we've written the format out to a data set, we can load that data set into CAS using the exact same code we just used in the previous slide. The only thing we need to do to recreate the format into CAS is to run a proc format with a control N equals and the CAS format lib equals option. The CAS format lib equals option points to the name of the CAS format catalogs or catalog that the format's going to be written to. This catalog could be a new catalog or a catalog that already exists. So this is the log that's generated by running that proc format code. We can see that the format was written to the myCAS format library. One thing that's interesting about this log is we'll notice the note is that both CAS formats and catalog-based formats will be written. The CAS-based formats will be written to the session CAS auto. And it tells us that the format library myCAS format's added and that the format search updated using the parameter pin completed. So what all those words are telling us is that in base 9 or SAS 9, we had to manually add the format catalog's location to the FMT search equals option. In CAS, that location is automatically added to the FMT search equals option. And so this is going to be our last slide of the day. Chances are that you'll want to use the format associated with the data set we just loaded into CAS in a subsequent SAS or CAS session rather. To make the format available, we will have to issue this line of syntax before we end our CAS session. This CAS statement uses the Save FMTLib option to save our format in a table. The FMTLib name equals option points to our CAS format library. The CASLib equals option points to the CASLib where the table will be stored. And then finally, the table equals option names the table that the format will be stored in. Before you start to move your data sets into CAS, you want to take a few things into consideration first. In today's presentation, we discussed 3 of these considerations in detail. Hopefully the information we discussed today will help you take the next steps needed to start taking advantage of the power provided by the CAS system. I'd like to thank everybody for viewing my presentation today, and I hope everybody has a great day.